Does it squeak? So, that's a long, I don't think that's working. There's a heart. A $600 heart? No. There's another long, here's the diaphragm. Let me take that out of there. All out of there. Okay, now we got down to the digestive parts. So, muscles out of the way. This is the, a couple of people are taking anatomy, right? Muscle? Sternocleidomastoid, the SCM, yes. My massage therapist is working on this all the time. Look at this muscle. When you get those headaches that radiate all over the place and they wind up like it makes your whole body do this, that's your sternocleidomastoid screaming. This thing connects to the mastoid process, which is back here behind your ear, and you can see it comes down and does this. So if you, like most people, tend to have really tight pecs because we sit like this in front of computers all day, or if you work out a lot and you work out these muscles more than you work out those muscles, you're this and not open. And so if you go for a massage or a acupuncture treatment or whatever, they stretch you this way and you go like, oh my God, that's really tight. And you'll feel it go all the way up to the side of your head, and that's your SCM. For most people, particularly when we work on computers and drive and our heads are like this all the time, those muscles tense up a lot and you feel a lot of discomfort there. You might not even realize it, and then when somebody loosens it up or a chiropractor cracks you a little bit, like you say, wow, that's better. Yeah. Anyway, that's the SCM that causes all kinds of trouble. Let's get rid of it. Okay. There we go. So, turn this way, and you'll see there's two tubes. The more ventral of the tube is not a digestive tube. That's your trachea. That, you know what the trachea is for. The dorsal one, the one that's more dorsally located, is the esophagus. That does have something to do with digestion. So, the esophagus is going to transport your food down to here and eventually get it into your stomach. Let's get that together. Hold on. Into your stomach. Here's your stomach. First off, it's important to note that you want the food to go in one direction and not the other. This should happen and that should not, unless you have a regurgitation reflex going on to purge the poisons. But normally, this is contained because there is a ring of smooth muscle here, involuntary muscle, called the cardiac sphincter. It's called cardiac because it's right near your heart, and if it's damaged or ulcerated, it feels like you have a heart issue, and in reality you have a cardiac sphincter stomach issue. That's heartburn. That's why they call it heartburn. So that's your cardiac sphincter. The stomach itself has three distinct regions, and in a physiology class they break them down and talk about what happens in each one. I'll just name them. You've got this sort of roundish part over here called the fundus, or the fundic region. There's the body of the stomach here, and then there's a little stem here that eventually connects to the intestine called the pylorus, or the pyloric region. The connection to the small intestine is also controlled by a sphincter that's called the pyloric sphincter, because that's the pyloric region of the stomach. So the food should be going like this and passing into the small intestine. Here's the very beginning of the small intestine, right here. There's this sort of little curled portion of it that comes up and around and down, up, around, and down. It's a relatively short piece of small intestine, like a foot, foot and a half long. It's called the duodenum. And then the rest of the small intestine, which is all of this, is comprised of really two distinct regions, the jejunum and the ileum. You can't tell which is which from this model because you would have to stretch it out and see. But sequentially, the regions of the small intestine are duodenum, jejunum, ileum. This is all on the handout I'm going to give you. Okay. The whole length of the small intestine is about 27 feet, or 9 yards. The phrase "the whole 9 yards" actually comes from that. I'm not making this up. This is really true. The idea that, in the old days of surgery, you take your guts out and put them to the side and work on you, and you had to put back the whole 9 yards of intestine before you sewed the person up. Otherwise, it didn't work well. So that's where the phrase "the whole 9 yards" comes from, believe it or not. Anyhow, you've got the small intestines eventually lead to the large intestine, which they paint in gray in this model. There's a again, a connection, a one-way valve that makes the food go this way and doesn't let it go that way. It's called the ileocecal valve. Ileo because the ileum is the last region of the small intestine. Cecal because the beginning of the large intestine, there's a structure called the cecum. It's not terribly prominent in humans, it's more prominent in herbivores, but that's why it's called the ileocecal valve. It's at the junction between small and large intestine. Anyhow, here's how it sits in your body. So this part of your large intestine, which is also called your colon, is the ascending colon. The digestive material is going up this way. Then you have the transverse colon, goes across. Then you have the descending colon, goes downwards. So up, over to the left, down. And then the last little bit of the colon is S-shaped, so it's called the sigmoid colon. The Greek letter sigma is the Greek alphabet version of the letter S, so sigmoid means it's shaped like the letter S. So there's ascending, transverse, descending, and sigmoid colons there. That's collectively your large intestine. The appendix is this weird little outcropping on the ascending colon. It's on the right side. If you're having the stabbing pain down here and it's on your left side, it's not an appendix attack. You didn't just burst your appendix. If it's on your right side, you should probably go to the hospital because you probably just burst your appendix. So, or you have appendicitis. So, just saying. Anyway, that's the appendix right there. One other thing. Anybody do yoga? Nobody does yoga? Come on, you're all exercise science majors. You don't do yoga? Really? Oh, you should. Loosens up your sternum like a massage. Anyway, in hot yoga, in Bikram hot yoga, there's a pose, I don't remember the Sanskrit name, and I'll think of it. But in English, it translates into the wind release pose. Makes you pass gas. So what you do is, on your back, you hold your knee with both hands, and you pull the knee towards the opposite shoulder as much as possible and rotate it a little bit. What that's doing is it's compressing this part of the colon. You do it with the right leg first, always. Then you do it with the left leg, because that way you're squeezing gases from here to here. If you do it left leg first, you're pushing the gases backwards up your intestine, and you're going to be in a lot of pain later on. So the instructor always makes sure that when you do this, you're using your right leg first, because that's a big deal.
Wait, why don't you use the left leg?
Because if you use your left leg first, gases from the descending colon are going to get pushed backwards, and now you just took gas and shoved it up your digestive tract instead of out. You're trying to get rid of it, not keep it. You're pushing it backwards because the drainage is that way. But if you do your left leg first, you're doing that, and you're going to push it back into your small intestines.
Okay.
So you got to go with the flow. So there you go. I think Debbie Van Buren does some. I know she does yoga on Fridays. I don't know if she does hot yoga down there. Not sure. Anyway, a couple other odds and ends here. That's your pancreas. In humans, it's shifted a little bit towards the left. It's dorsal to the stomach. The stomach's sitting right there. So there's your pancreas. You know all about pancreas. We covered that a lot. It also has a digestive role besides making glucagon and insulin. There's digestive fluids that come out of there. We will talk about them next soon. Whenever before the end of the semester, we'll talk about them. Shoot that wrong stuff. And then the liver. Here. The liver in humans is shifted towards the right, just under the diaphragm. And one of the functions of the liver is to make bile, which is going to assist you in doing digestion. And humans have this nifty little gallbladder to store the bile in and then release it when it's needed. There are hormones that control the contraction of this gallbladder that will send bile from here through a bile duct into the small intestines where it's needed. Not all mammals have gallbladders. Some, for example, rats don't have gallbladders. They just directly send the bile from the liver into the small intestine, so it's not regulated as carefully. For us humans, if you have a functioning gallbladder, you make hormones, and bile helps digest fat. So the more fat you eat, the more bile you send. The less fat you eat, the less bile you send. It's kind of a supply and demand thing, and we'll talk about those hormones soon. So there's your digestive parts. The only other things that are on the list that I'm about to hand you are just a couple anatomical directional terms. I gave you two already. Superior versus inferior. I could say that, let's put the stomach back in here. Oops. There we go. I could say that the trachea, the diaphragm. Here. The diaphragm is superior to the stomach. The stomach is inferior to the diaphragm. It just means above and below, superior, inferior. Lateral and medial. Lateral means to the side, medial means to the middle. So I could say, so with respect to the midline, right, here's your midline. With respect to the midline, I could say the heart is more medially located than the deltoid muscle. The deltoid is more lateral than the heart, which is further from the midline, which is closer to the midline. That's all. And then one other set of directional terms, proximal and distal. Proximal means closer to, distal means further away. So I could stick a couple of pins in my arm here, and I could say, with respect to this pin, my elbow is more proximal, my wrist is more distal with respect to this. If you're not given a point of reference, assume that the point of reference is the midline. So even if I didn't put that pin there, my elbow is more proximal, my wrist is more distal. That's all. It's just good terms to know. Okay. Questions? All right, I'm going to run back and get that Xerox copy of all of the stuff I just named. You guys can go through the models, these, we've got another one back there, you got these, you got, if you want to open up slides, whatever you want to do, it's all your call. Okay?